Hello, and welcome to Proving the Concept, where we dive into the weird, wonderful, and occasionally bizarre corners of science and technology. I'm your host, Sarah Goffin, and today we're going subatomic. Yep, we're talking about quarks, the tiny building blocks that make up, well, just about everything. Quarks are fascinating. They're fundamental to the universe, they have some of the quirkiest names in science, and they hold the key to understanding everything from atoms to the Big Bang. So stick around, because by the end of this episode, you'll not only know what quarks are, but you'll also have some fun facts to impress your friends. Oh, and we'll finish with a quick spotlight on a trailblazing female physicist who has worked on this area. So let's get Quarky. Okay, so what exactly are quarks? At their core, pun intended, quarks are elementary particles. They're one of the fundamental building blocks of the universe, according to the standard model of particle physics. Now, here's the cool part. Quarks combine to form hadrons, which are composite particles. The most famous hadrons are protons and neutrons, the building blocks of atomic nuclei. So, in a very real sense, quarks are what make up the matter around us. There are 6 types of quarks, or as physicists like to call them, flavors. The names are up, down, charm, strange, top, and bottom. Yes, you heard that right, charm and strange. And before you ask, no, physicists weren't having a casual drink when they came up with these names. Well, probably not. The name quark itself was borrowed from James Joyce's Finnegan's Wake. It's science with a side of literary flair. But here's where things get interesting. Quarks never exist alone. They're always found in pairs or triplets because of a property called confinement. This is due to the strong nuclear force, which is mediated by particles called gluons. If you're picturing quarks glued together by invisible glue, you're not far off. Think of quarks as ingredients in a recipe. Alone, they're just a list of things, but mix them together and you'll get something meaningful, like protons and neutrons, which are the bread and butter of atoms. So, why should you care about quarks? Well, without them, there'd be no matter. No protons, no neutrons, no atoms. Basically, no universe as we know it. Every time you look at your phone, drink a cup of coffee, or even breathe, you're interacting with matter built from quarks. But quarks aren't just foundational to everyday life. They've also played a huge role in advancing our understanding of physics. Their discovery helped cement the standard model, which is essentially a cheat sheet for understanding particle interactions. It's like the ultimate guide to how the universe works. And let's not forget particle accelerators like the Large Hadron Collider at CERN. These giant machines smash particles together at near-light speeds to study the behavior of quarks and other particles. The results help physicists explore everything from the early universe to exotic forms of matter. Quarks may be tiny, but their impact is massive. Let's shift gears and talk about the quirks of quarks. One of the strangest things about them is something called quark mixing. This is where quarks can actually change flavors, like an up quark becoming a down quark. It's like ordering vanilla ice cream and watching it turn into chocolate mid-scoop. And then there's quantum behavior. Quarks have properties like spin and color change. Now, the term color here doesn't mean actual colors like red or blue. It's just a metaphor physicists use to describe how quarks interact. Here's a mind-blowing fact. The mass of the quarks inside a proton only accounts for a tiny fraction of the proton's total mass. Most of it actually comes from the energy of the strong nuclear force field. Yes, Einstein's equation E=mc² strikes again. Oh, and if you're a sci-fi fan, you might have heard of Quark, the Ferengi bartender from Star Trek Deep Space Nine. While not scientifically accurate, it's fun to think of him as an homage to the quarks we're discussing today. Now, let's take a moment to shine a spotlight on someone who's made quarks her life's work, Dr. Mary K. Gaillard. Dr. Gaillard is a theoretical physicist who played a crucial role in developing the Standard Model, the very framework that explains quarks and their interactions. She was the first woman to hold a tenured position at CERN, the world-renowned particle physics lab, and her contributions are nothing short of breathtaking. One of her most notable achievements? She predicted properties of the charm quark before it was even discovered. Talk about being ahead of the curve. But Mary Gaillard wasn't just a brilliant scientist, she was also an advocate for gender equality in science. Her career has inspired countless women to pursue physics and has helped pave the way for greater discovery in the field. Her story is a powerful reminder that science isn't just about equations, it's about the people behind them. And that brings us to the end of today's episode. We've explored the 6 quirky flavours of quarks, how they build the universe, and some of their more mind-bending properties. Plus, we celebrated the incredible contributions of Dr. Mary Gaillard, a physicist who helped shape the understanding of particle physics. Quarks may be small, but they hold the key to some of the biggest mysteries in science. Whether you're a physics fan or just someone who loves quirky stories, I hope you've enjoyed this dive into the subatomic world. Thanks for tuning in to Proving the Concept. If you liked this episode, don't forget to subscribe, share it with a friend, and leave us a review. And as always, keep exploring the weird and wonderful world of science, my curious minds. Until then, I'm Sarah, signing off.